Let's look at an example from our last video to explain what the complex conjugates theorem states. After factoring by grouping, we found out that the first zero is -3. But what's more important for the topic today is that we also found two zeros with an imaginary number. Recall that a complex number a+bi has a real part, which is the a, and an imaginary part, which is b. Also recall that the complex conjugate of a+bi is a-bi, and that the complex conjugate of a-bi is a+bi. When we look at these two zeros, we see that -4i is the complex conjugate of 4i. And this is exactly what the complex conjugates theorem states. It states that if we have a polynomial function with real coefficients, and when we have an imaginary number as a zero, like 4i, then -4i is also a zero of the polynomial function. Which makes sense because when we take the square root of a negative number, we always get two imaginary numbers as zeros, which are complex conjugates of each other. In other words, complex non-real zeros come in pairs. Let's do some more examples for the sake of practice. Let's say 1 plus 2i is a 0. Then 1 minus 2i is also a 0. What about 2 minus 5i? If 2 minus 5i is a 0, then 2 plus 5i is also a 0. Let's say 7 plus 3i is a 0. Then 7 minus 3i is also a 0. It's obvious that this works only if b is not 0. Because if b equals 0, we have a complex number with no imaginary number part anymore. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.